So now that we've got the stroke working here on the circle, let's go ahead and get the stroke working on our squares. So I'm going to come here to my rectangle function, and basically I'm just going to mirror exactly what's going on here with the ellipse. I might have to make a few adjustments here and there since the formula of the rectangle is slightly different, but I'm going to have it roughly kind of mirror the same structure. So that means right away, I'm going to have new arguments in here. I'm going to put in a float of stroke size, and I'm going to put in stroke color. And then I'm going to do the same thing where I accumulate a color. And I'm going to return a color. And then all of this is going to change. I'm going to get rid of that because I'm going to use the method I'm using up here. I'm going to be assigning, instead of rect step, I can see right here, that's circle step, but I need to add the size plus the stroke size times 0.5 so that I have that inner size. So down here on rect step, I'll change this to step 0 rect plus the stroke size, the same code basically. I can just copy and paste. There we go. And then to add to the fill, color plus equal rect step. And then I'm going to multiply by fill color. Same as I've got going on up there. And then I need to build my stroke. So once again, float rect step stroke. And then I'll call my rect step. And I'll subtract by basically the same rect step that I've got going up here. But I need to copy and paste. Instead of adding, of course, I'm going to subtract. And then I'm going to assign that right in here. And that'll be rect step stroke times fill color. And I forgot to put those, of course, here. So let's go ahead and let's float in my stroke color and my stroke size, which comes right before fill and right before rounding. So I might want to give myself maybe some, I might give myself some hints for that, of the order of the arguments there. But yeah, just for now, let's just do stroke size. Okay, and let's go and jump down here to the square. Ooh, okay, that's not working. Let's take a quick look at our code. Okay, so if I take a quick look at this, I'm getting all white, and if you're getting all white, that means you're probably getting the inverse somewhere. So, and I think this is because I'm actually running this in reverse here in the circle. I'm starting the outside and working my way in, but because of the way this formula works from the inside out, that's why, as you recall, I had to reverse it with 1.0 minus. So I'm going to do that both places. And then that means probably I have to add there instead of subtract. Cool, and that's giving me, oh, and I see one more error. That's changing the rounding, so these are, looks like these are reversed. And let's see, size, fill, stroke color, stroke size, fill, stroke color. Yeah, let's reverse the order of the arguments here so that's consistent between the two functions. There we go. And there we go, it's working. Cool. So we've got ourselves our square with our stroke. Notice this is kind of nice. The stroke actually takes on the rounding as well. So probably, oh yeah, let's just do it. Let's make ourselves a rounding control as well right underneath stroke size. So underneath stroke size, I'm just going to copy and paste that. And let's call it rounding and rounding. think is fine. There we go, and let's pass that in. Let's see, the float rounding is equal to rounding, so let's also do a float of rounding here. And call this round is equal to rounding, I guess. I don't know. This is maybe silly to do this, but and then let's replace that 0.0 with round. There we go. So now we've got a nice control for the rounding, and it looks like that value is set way too high. So let's come here to rounding, and the max is 0.5, which seems like that max can be a lot lower. There we go. So we make a nice big size box, and that's, you know, you can fiddle with those numbers, get the rounding that you want. Cool. All right. So I would say probably the next thing we want to do is, it's definitely bugging me a little bit that it's all additive blend mode. I think these shapes will just look so much cooler if we are able to kind of like change their blend modes for add, multiply, and over. So I think that's what's going to be next for us, is to add in some different blend mode types. All right, so next what I think we need to do is build an alpha channel for our shapes so that they return transparency around the edges of the shapes. That still isn't going to help us with blending modes, but it's a start. So the first thing I think we need to do is observe right now that our shape functions, ellipse and rectangle, are returning vec3s, which means essentially they're just returning the red, green, and blue values. Then down here in our main function, when we're assigning to GL frag color, we're just assigning the RGB inside color, and then our alpha is actually just this solid scalar value. This is solid 1.0. So ideally what I'd like to do is get rid of that and just pass in red, green, blue, and alpha for each of these shapes. So let's get started on that. Well, the first thing I need to do is convert these from vec3s to vec4s. That way they're going to return red, green, blue, and alpha. And in both of these functions, I'm going to also accumulate a vec4. So instead of accumulating a vec4 color and returning a vec3 color, vec3 color and returning vec3 color, I needed to do vec4, of course. Great, and then down in here, I'm going to assign color, and I'm going to do the same thing here in my, I'm using the same methodology here in my main. Rather than accumulating a vec3, I'm going to accumulate a vec4. Okay, and one more slight change I can see here in my two shape functions, that this is a vec4, but fill color is a vec3. So I'm going to just assign that to the R, G, and B. I'm going to send that into the RGB. I'm going to do that both places as well. And I'm doing those simultaneously right there. So actually I'm just going to do all my color assignment in line like that, so it's consistent. And I understand I'm kind of developing this ellipse and rectangle in parallel. There's a lot of overlaps between the two. Maybe eventually it'll make sense to just have one overall function called shape, and then, you know, I pass it a type, and then it branches off the code kind of in here in the construction. I'm not quite sure yet, but I don't know. I'm making kind of an argument to myself here as far as encapsulation is concerned. Okay, so let's save and let's run that. And great, yeah, great, we get nothing. And that's because, of course, it's returning an alpha channel with no value in it. So we need to build some alphas for these guys. And how are we going to do that? Well, I built a quick little diagram here so that we can kind of actually remember what we're doing. Okay, so remember, we're starting with an all black kind of space, and then we're doing a shaping function that is going to be returning essentially like this distance field, right? Like from that point, and then we're stepping it. So this is basically when we run our distance field formula, which is length, just in the case of the circle. It returns something that looks like this, you know, whatever, a circle. And then what we're doing is, so that means we have black values and we have white values, but really this is a float value. This is the value of every single pixel. So every single pixel is either returning a 0 or it's returning a 1 if it's inside the circle. And then we're taking those 0s and 1s and we're multiplying them by a vec3 that we're passing in in this example, I've chosen lime green. So 0.2, say, probably in the red, 0.9 in the green, 0.2 in the blue. So that 1.0 is then going to get multiplied by these values. If this is a 0, then it'll be 0. If it's 1, then it'll be equal to that number. So inside our vec4 now, we're accumulating 0.2, 0.9, and 0.2 for the fill. Then we're doing that whole operation again, but this time we're doing it with the stroke. So this is what's happening here in the case of the ellipse. That's what this is, right? It's like it's calculating the circle, and then it's multiplying it right here by the fill color. Keep in mind I'm subtracting the stroke size here, but basically that's what's happening. Then I do this whole thing again for the stroke. Like I calculate the stroke, I minus the size, I do it twice and minus the inner size, and then I multiply by another RGB, which is the stroke color. So let's say this is the result of our second shaping function. We have zeros and ones, and I'm going to do the whole thing again. And then now this is going to be built up of, it depends on where your pixel is at, but it'll get this number if it's inside of the stroke. So it'll just get 0.5, 0.5, 0.5. Great. And that's what we're doing right now. So the fill and the stroke, after we multiply it by their values, they look like this. Great. Okay, so building the alpha channel is actually going to be really easy because we have a float value already. All we need is the fill and the stroke before they do before they multiply by their vec3s. And since those are floats, I think we can just shift them right here into the alpha. So let's do that. Okay, so down here, color.rgb, let's say color.alpha is equal to just the fill plus the stroke. So that would be this and this. And let me make sure that that's working. And there we go. We've built an alpha channel. Let's do it on the other one too. Color.a plus equal, and we need to just add in this fill, the stroke, respectively. There we go. Great. Okay, so that's the first step in building some blend modes. So now we're at least returning the alpha around our various shapes.